В общем, мы хотели попасть в музей Николы Теслы, но там по расписанию сербский, английский, и еще кеш.
Английский.
Кель кеш.
Кэш, да.
Кеш. Кель.
Динар.
Один динар?
Да.
Динар?
Нет, не всегда.
Не знаешь. В общем, картами не принимают, евро не принимают, принимают только динарами, а мы не спросили даже, сколько стоит. Музей, ну, нет проблем. Экскурсия будет на английском языке. Бертран будет слушать, а я только смотреть. Вот. Это еще какое-то красивое здание. В общем, сейчас нам нужно 40 минут погулять, потом мы вернемся снова в музей. Мы находимся в музее Николы Тесла. И не все можно снимать, поэтому я частично буду снимать. А когда будет экскурсия и шоу, тогда съемки уже не будет. Сейчас история. Традиционная личка торба, ручной из Рады. Трудник. Притча о рождении Николы Теслы.
Брат папа.
Брат папы? Саквояж. Насколько я понимаю, это крокодил. Аллигатор? 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 Крокодил?
Да. Да, крокодил.
Костюм.
Никола Тесла костюм.
Жали. Электродинамометр, ваттметр, таласометр, Это Никола Тесла? Апри фотосъем. Это урна, прах. Это прах.
И?
Прах. Урна, мор.
Ким?
Это. Селямор. Никола Тесла.
Да.
Это урна.
Да, урна.
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 Никола Тесла умер, и это урна Никола Тесла. Урна с посмертным пеплом. Прах. Это
Да?
мор прах.
Electricity. Scientist electricity.
Это все люди, которые имели отношение к электричеству, да? Электричество.
History of electricity.
История
Historia
электричества.
electricity. Benjamin Franklin, Galvani, amerykański, italiański,
Александр.
italiański, francuski.
Не знаю женского. Да. Нет видео. Хорошо. Да. No far видео. Да? Хорошо. Все, видео у нас нельзя делать. Так что пока-пока.
And it turns it into electricity that has kept 1 million of volts. Now, in order for us to understand how does that happen and why would we need in the first place electricity that has kept 1 million of volts, we will need to understand the construction of Tesla's coil. So for that, in that manner, I will ask you to consider Tesla's coils to be systems consisted of two coils. So therefore, every Tesla coil needs to have the primary coil and the secondary coil. Although the very beginning of the whole principle is in this part over here, where the high frequent electricity is generated, which we apply then through the primary coil. Because of that high frequent electricity in the primary coil, there will be a strong magnetic field created around the primary coil. And that magnetic field is very important because it induces or creates the electricity into the secondary coil by literally making the electrons from the copper wire in the secondary coil move. Now all of the electricity from the Tesla's coil needs to find the closest grounding, which is in this case the metal sphere at the top. So the bare process of electricity trying to get from its source to its grounding we call the electrical discharge, and break into the ions. Raindrops, and that actually that occasion is called the ionic rain. You will see that these neon lamps will light up without any physical contact with the source of electricity. And that is the primary purpose of every Tesla's coil, the wireless transmission of electrical energy. So we will have fully functionable neon lamps without any physical contact with the source of electricity. All right? Yes, quite. Before we start, I have a question for you. So does anybody here in the room have a pacemaker? No? You sure? Okay, next question. Does anybody here in the room have a will to volunteer? I'm looking for a yes here. Thank you. Okay. I have few more neon lamps, so I'll be happy to. All right.
Do I need to get colder?
Sorry? Oh, I'll explain in a few seconds. Anybody else? Few more. No problem. And one last one. There you go, sir.
Thank you.
Okay, I'll ask everybody who has a neon lamp to make a half circle around this neon, around this metal fence over here. So please do come closer. Okay, so there are three simple but highly important rules that you will need to obey in order to stay safe during the experiment. The first and most important rule is not to cross the metal fence with any part of your body or your neon lamp at any point during the experiment. So please stay behind the metal fence. Hold your neon lamp straight up at the bottom of the neon lamp and behind the metal fence, yeah. And third and last rule would be do not raise your neon lamps, so do not push them up. Good? Yeah. So any questions?
No.
No. So that means you're ready.
Yeah.
Are you excited to see this lightning?
Yeah.
Good. So I will turn on the Tesla's coil 3 times, that will give you 3 warnings. So just enjoy the experiment.
No video, Fernando.
Survivors. Yeah, too many. So just enough to continue. You can tell them when tell the difference when they're turned off.
What the maximum distance it would sorry the maximum distance for those ions?
Yeah, I think it's like this room, this space over here.
Yeah.
I think if you went to the end of the room, that you won't be able to
Yeah.
in this case. So you can like
Then
you
bigger-
can set the distance.
Yeah, you can make it bigger. But
Yeah.
what the electricity consumption of it, like the electricity consumption
Yes.
of all the system.
Oh. How many?
Watt.
I'm not very sure. I have those information. I can give it to you after
No,
the tour is
no,
ended.
no.
Yeah, I don't have it on top of my mind.
What happened if I
Well, if you were to cross the metal fence like this, you're endangering yourself to become the closest grounding. So if you're closest, then that metal sphere. Yeah, you would be the grounding. The lightning would jump out of the primary coil, and it would ground in you, and it would have like lower frequency and lower voltage, but it will be stronger, so you could get like burned, and you won't die, but you will get injured.
Can you
so.
charge my phone?
No, it's too low in amperage. We're working on that. Okay, I'm glad that you enjoyed this. Thank you for nothing alike, but the principle they work by is the same. The only major difference is that it produces electricity that has 250,000 volts. When I turn it on, you will see an electrical discharge over here, and you will see these two neon lamps light up. When you see the upper neon lamp, actually I would ask you to pay attention even now, you can see. Upper neon lamp is actually a written word in Serbian, in Cyrillic letter. So, and the word that is written is the word zmaj. So zmaj, when we translate it into English, we get the word dragon. But why does it say the dragon on top of Tesla's coil? I think that you may be wondering what is the connection here. Actually, that is a quite interesting story, because during Tesla's lifetime, he only had one visit to Belgrade. And during that visit, he was welcomed here with a grand celebration, during which the main word was held by Serbia's famous poet, Jovan Jovanović Zmaj. So Jovan Jovanović was poet's name and last name, but the Zmaj was his nickname, and he was very known for his nickname. So Tesla felt inspired by him, and he dedicated this machine to him, therefore. And that is something Tesla did. He sometimes kind of dedicated his inventions to some of the big names of Serbia. Let's see how it works. First time. Second time. Third time. Magic. Yeah. All right. I hope you enjoyed that. Now we will move on to the next model. I want to present to you Tesla's boat. It's right over here. So Tesla's boat is the first ever constructed remote control toy. But this invention is, of course, a lot more than just an ordinary toy. It's because with this invention, Tesla actually found the way for us to use signals, to use electromagnetic waves. This is the first wireless system ever to be constructed, and this technology is the base of all the technology, all the wireless technology that we use in 21st century. And I'm quite sure that you noticed how wireless technology is getting popular these days. So everything wireless is popping out new. So you have wireless earphones, wireless charging, wireless this, wireless speakers, and so on and so on. So there is a lot of steps forward in wireless technology. And the base is this invention that standing in front of you now, the first ever constructed wireless system. So let's see how it works. So everything starts with a remote controller, of course, which has 2 red buttons and 2 Tesla coils. When we press these 2 red buttons, these 2 Tesla coils will get activated and they will send 2 signals that have their own specific frequencies. So we will have 2 signals that have different frequencies traveling to 2 antennas that have matching frequencies to those 2 signals. So therefore, signals will recognize these antennas, they will go through them, and they will enter the AND logical gate. AND logical gate means that one and the other signal needs to be received, therefore sent, in order for both to understand the command. So if you're operating the boat, you need to press both red buttons at the same time, because only then will the AND logical gate give the command to the battery to move these mechanical parts over here that are responsible for the moving of the propeller and the stir over here. Now I will show you how this boat actually works. And I'm quite sure that this part of the crowd won't be able to see this experiment because it's just the back side of the boat that is moving. But after the tour is ended, I'll be glad to show you, to turn on this experiment one more time for you. I will just ask you to please remind me of it because I'll just wander off and I will forget, but I want you to see it. Just please remind me and I will do this experiment one more time for you. Good. Are you ready? Mm-hmm. Here we go. The boat actually has 2 commands. First one is for the propeller to start moving, and second one is for the stir. I will just ask you now to move a few steps back. I think there is plenty of us in the room and we're all acting like conductors. We will try this again. Okay, first command for the propeller. Second one is for the stir, but the stir is working. Okay, so you can see now that the stir has its natural route. It goes from the one final end to the other. Of course, you can stop the stir and make it go at any time as you wish. You can see that if I stop the stir somewhere in between 2 final ends, the propeller does not stop. And that is how you get to determine the direction you want the boat to go in. That's why the propeller stops only when the stir reaches its final point. Actually, Tesla constructed this machine in 1892, and he presented it to the public of New York in 1896. So that is the end of the 19th century, if I'm correct. When he made a presentation with this machine, people were amazed. So people could not believe that Tesla was actually moving the boat. He was directing the boat without any physical contact with the boat. It seemed quite impossible for them. So some of the people that attended that presentation thought that Tesla was certainly using wires. So they jumped inside of the water in the search for wires. But when they did not find any wires, they started making stories about Tesla because they could not grasp the point of signal. It was unimaginable to them. So they thought that Tesla was a magician. They thought that he put a spell on the boat and made the boat move according to his will. And they seriously find it more logical than a signal. They thought that Tesla was a monkey whisperer, that he trained a little monkey to read his mind, put a monkey inside of the boat and made the monkey move the propeller and the stir. And some of the people thought that Tesla used telekinesis. Everything seemed more logical than electromagnetic waves. It was just unimaginable to them, which is quite the reverse now. So today, we cannot imagine our life without signals. So we just rely on them at every single day. All right. With all this said, I just want to direct your attention to. So standing in front of you now is yet another Tesla coil. It looks a bit more like the first Tesla coil, but it has a primary coil. It has a secondary coil. But my question is, what is missing? Sorry?
The discharge.
Discharge, very well. We're missing the discharge here. And that's quite a problem because I wanted you to see this experiment, but I will need a grounding, a discharge. So please, you can just not take video. Alright, good job.
Çok
Good job.
Инструкция, как носить маску. Фу, тут так пахнет, пиписьки тут.